Welcome back to the Deep Dive. Today we are opening the source code and really digging into a security bulletin that has, well, genuinely rattled the foundations of the modern web.
It really has.
We're talking about a critical vulnerability in Node.js, and that's the runtime environment that, whether you realize it or not, handles the backend for, almost every major service you use daily.
And the severity here isn't theoretical. This is a critical, very practical threat. This vulnerability lets an attacker trigger a complete denial of service, or DOS condition.
Just by feeding it some bad data.
Exactly, just a specific malicious input to your server. And given how, ubiquitous Node.js is, this needs immediate action. It's the kind of thing that can bring a whole platform down faster than you can yell, "Stack Overflow."
And that is the exact phrase we need to focus on: Stack Overflow.
Yeah.
The official bulletin from the Node.js team is the core of our deep dive today. They called it a critical security issue impacting virtually every production Node.js app. That's not marketing copy. That's a statement of architectural panic. So our mission is to unpack what that means. How does a simple, classic programming concept like recursion getting out of control suddenly become this uncatchable fatal flaw? Okay, let's unpack this.
It really does highlight the critical nature of core infrastructure. When you have a bug at the root of a massive dependency tree like Node.js, the consequences they radiate outward exponentially.
Right.
Fixing that one point addresses thousands of downstream risks instantly.
So for our listener, if you're in development, you already know Node.js is basically the backbone of the modern web. It's what lets JavaScript run on servers. But we're not talking about like a minor third-party library flaw here.
No, not at all.
We're talking about an instability deep inside the engine's core. When we say it affects the ecosystem, we mean foundational tools are suddenly unsafe.
And that scope is exactly why the technical advisory was so alarming. What's fascinating here is just the sheer breadth of tools they explicitly mentioned that rely on this broken mechanism.
Yeah, I saw some heavyweight names on that list. What stood out to you?
Well, absolutely. Beyond just custom apps, we're seeing front-end frameworks like React Server Components and Next.js getting hit.
Which are central to how people build today.
Exactly. But even more telling are the application performance monitoring tools, the APM tools. Datadog, New Relic, Dynatrace, Elastic APM, OpenTelemetry, all of them.
Wait, all of them?
All listed as affected. Think about that for a second. The very tools you rely on to monitor your service uptime are themselves introducing a single point of failure that can cause total downtime.
That is a wild intersection. A UI framework and a logging tool, both carrying the exact same vulnerability vector. So what's the common thread? What's the fragile piece connecting them all?
The thread leads directly to a component called AsyncLocalStorage. That's the key. It's the piece of context that relies on the faulty, low-level API.
Okay, so break that down for us. AsyncLocalStorage, what does it do in simple terms?
Think of it like this. When a user sends a request, that request bounces around, right? Multiple functions, a database call, maybe a cache lookup. It's an asynchronous journey.
Sure.
AsyncLocalStorage gives you a persistent bag of context that follows that single user request through its entire journey, no matter how complex the path gets.
So if I'm tracking a user session ID or something, that context has to stick with the request, even if it's waiting for a database. It's like a medical chart following a patient through a hospital. That's a perfect analogy. And that medical chart is crucial for observability, knowing who did what and when. And to do that, AsyncLocalStorage is built right on top of Node.js's lowest level concurrency API, the async hooks module. Okay, so if that foundation, the plumbing for all this async stuff, is faulty, then everything that uses it inherits the instability.
Precisely. From Next.js tracing to Datadog monitoring, it all becomes unstable.
Okay, so we get the scope. Now let's dig into how a simple recursive bug breaks the whole system. Let's talk about those async hooks.
Right. We're drilling down into the core mechanism of failure. You've got two key players. First, as we said, async hooks. It's the low-level API that tracks the lifecycle of every asynchronous resource. It sits right next to the runtime engine.
And the second player?
The trigger. And that's stack space exhaustion, the classic Stack Overflow. It's just when a function calls itself too many times deep recursion, and it runs out of memory on the call stack.
And the sources note this is often controlled by unsanitized input. That's the security link, right? The attacker isn't writing code, they're just supplying data that forces existing code to run too deep.
Exactly. Imagine a JSON payload that references itself over and over, creating this monstrously deep object. or malicious input to a templating engine. A standard app should handle that gracefully.
And this is where the system's resilience just completely breaks down. Help us contrast the intended behavior with what actually happens with this bug.
Okay, so under normal circumstances, when Node.js is just running on the V8 JavaScript engine, V8 is actually pretty robust. If it detects stack exhaustion, it makes a best effort attempt to recover.
How does it do that?
It throws a standard catchable error and exception. This is the critical piece. Every robust framework relies on this. They wrap their code in a try.catch block. They log the issue, maybe return a 500 error, and crucially, the rest of the app stays online.
So the system should absorb the punch. It fails gracefully.
It should. But the bug introduced by AsyncLocalStorage completely sabotages this recovery mechanism. When AsyncLocalStorage is enabled, which remember it is if you're using any of those major APM tools, the runtime's attempt to generate that catchable error fails internally.
Wait, so a utility module is overriding a core behavior of the V8 engine itself? How does a module get that much power?
Because AsyncLocalStorage operates at the absolute lowest layer of the Node.js execution loop. The sources explain that instead of throwing that recoverable exception, the internal state becomes inconsistent. The process just can't recover.
So instead of an error for the developer to catch,
Node.js just exits the entire process instantly.
and that's signaled by the infamous exit code 7.
Precisely. Exit code 7 means internal exception handler runtime failure. It's an internal disaster signal. It means the application has failed so badly that its own error handling has crashed.
So no cleanup, no logs, nothing.
Nothing. The server process just vanishes. If an attacker can trigger this repeatedly, they achieve an immediate and, frankly, trivial denial of service.
Wow. That takes a simple application fault and turns it into a system-wide security catastrophe just because a tracing library was turned on.
It really makes you question the cost of deep observability. You trade a little bit of resilience for that detailed tracking. Okay, let's move on to the fix. Section 3. We have the vulnerability ID, CVE-2025-59466. It's got a CVSS score of 7.5, which confirms significant practical impact. So what are the life-saving versions people need to move to? The fix has been applied across all the currently supported LTS long-term support lines and the current branch.
So what are the numbers?
The patched versions are Node.js 20.2 Ever.0, 22.2 Butterway 0, and 24.13.0 for LTS users, and 25.3.0 for anyone on the current branch. If you're on an active support line, you need to be on one of those.
But the problem goes way back, right? This affects some seriously old deployments.
Oh, it does. This architectural flaw could impact every version of Node.js going back to 8.x, that's codenamed Carbon, which first introduced AsyncLocalStorage way back in 2017.
And critically, every version between 8.x and the current 20.x lines.
It has reached end of life, which means if you're running on 14, 16, or 18, you are permanently vulnerable to this. There is no patch available for you unless you do a major runtime upgrade.
And we know that's not a weekend project. Migrating a massive, complex legacy app off an old LTS version is a huge undertaking.
It is. The inertia is very real. People stick with older versions not because they're negligent, but because critical dependencies haven't been updated or the migration itself just breaks too much. It's a huge business risk that many have just, accepted.
So how did they actually fix it? They couldn't just rewrite V8. The solution wasn't to prevent the recursion itself, was it?
That's exactly right. The solution is very pragmatic. The engineers put code in place that specifically detects when the Stack Overflow is about to happen while AsyncLocalStorage is active.
Yeah.
Instead of letting that fatal internal failure happen, the runtime intercepts the error and just rethrows it to the developer's user code.
So it restores the original expected behavior.
Exactly. It restores predictability. The failure becomes the expected catchable exception again. The developer's try.catch blocks can now do their job, log the error, and prevent the catastrophic process crash. They fix the resilience layer, not the user's code.
Now here's where the philosophy gets really interesting. Node.js said they are treating this fix as only a mitigation, not a full security fix. Why would they downplay something that crashes basically every production server?
That nuance connects us back to core web standards. The V8 JavaScript engine, which Node.js uses, doesn't fundamentally consider stack space exhaustion a security vulnerability. To them, it's an implementation detail, a resource exhaustion error.
Why? Why isn't running out of memory a security risk to them?
It ties back to the ECMAScript spec. The official spec defines how JavaScript behaves, but things like stack space limits aren't mandated by it.
Okay. They're dictated by the OS and the V8 implementation. So V8's perspective is, if user code has an infinite loop, that's a developer error. The engine's job is to run code, not guarantee infinite resources. So the Node.js engineers are basically saying, technically V8 doesn't owe us a fix here, but practically the real world is on fire, so we have to patch it anyway.
Precisely. It's a great example of pragmatism winning over strict adherence to a spec. They chose to put it in a security release anyway, citing the, undeniable practical impact. They recognize that while it might not be a security issue by V8's definition, an attacker weaponizing it for GOS makes it a priority in the real world.
The necessary step to keep the ecosystem running. Okay, let's move to immediate action and the bigger picture. The call to action seems pretty simple and urgent.
It couldn't be clearer. Users of any of those affected frameworks, any of those APM tools, and critically, all server hosting providers must update to those patched Node.js versions as soon as possible. But there's another layer of responsibility here.
And what's that?
Node.js explicitly recommended that maintainers and developers apply more robust defenses to counter stack space exhaustion themselves. This is key. The runtime fixed the fatal crash, but developers shouldn't just rely on that.
So the fix prevents exit code 7, but you still need application-level input sanitization and depth limiting. Those are still essential.
Absolutely. If your app handles deeply nested data, you have to have your own checks to limit that recursion deck before it ever exhausts the stack. It raises that ongoing question, how much resilience should be in the core runtime versus the application layer?
And the answer is always both. A layered defense. And this deep dive on CVE-2025-59466. This is just one part of a really critical patch cycle overall, wasn't it?
It was a major cleanup, yeah. The disclosure came with fixes for 3 other high-severity flaws. For instance, 2 of them, CVE-2025-55131 and CVE-2025-55130, related to data leakage and letting an attacker read sensitive files using crafted symlinks.
File system access via a link path, that's always a nightmare scenario.
And on top of that, there was a separate flaw, CVE-2025-59465, that could also trigger a remote denial of service, just through a different vector. So while the Stack Overflow got all the attention, the whole patch was critical. Okay, so to summarize what we've unpacked today, a critical architectural bug, CVE-2025-59466, meant that a routine programming mistake Stack Overflow was instantly transformed into an application killer, triggering a fatal DOS via exit code 7.
Right. And this one small failure point impacts the foundational tracing and monitoring tools used by virtually every major modern web service on Node.js.
And that fragility brings us full circle to those unpatched systems. We know that critical Node.js versions X through 18.x are permanently vulnerable because they're end of life. So here's a final thought. Given how fundamental things like async hooks are to the ecosystem, what does the continued dependence of production systems on unsupported infrastructure tell us about the hidden risks we accept, just for the stability of staying put? When that foundation fails, the cost of not upgrading eventually comes due. That's something for you to mull over as you review your own application dependencies.